My name is Zhi Wu. I'm an architect from Oracle Spatial and Graph. And this session is about bridging RDF graph data model and the property graph data model. A lovely safe harbor statement. Too many legal jargons, so. Okay, so what is a graph? A graph is nothing more than linked data. Okay, so this is the best definition I'd like to use when describing a graph. What this is representing entities, edges representing relationships and links. Okay, at Oracle we have a clear strategy to handle graph data. We treat graph as yet another data type, right? When comparing against spatial data, relational data, JSON data, right? We support graph as a data type on all kinds of platforms. Hadoop platforms, Oracle Relational Database, and of course, the cloud. Now, I'm from the product team, okay? In my team, we are following three kind of major directions. The first direction is we have been shipping RDF and R Sparkle product, right, for about 10 years now. So we are continuing improvement, adding more features, improving the security, improving performance. Okay, so there's ongoing work in this direction. So in the past few years, we have also invested heavily in the so-called property graph data model. We have shipped property graph support on big data platform from last year. Okay? And we are going to have property graph support in Oracle database in the upcoming database release. There's also a third dimension of other data types. So for these other data types, we are looking at spatial data, relational data, and JSON. Okay. If someone is telling you, hey, I have a great piece of graph technology, it can solve all your business problems, it's likely you're talking to a business person, a sales guy. Okay. In reality, what we have found is, and graph technology can play a crucial role in an application, but rarely it is the application itself. Rarely it is the solution itself. So it's a part of a flow. So in addition to these three major directions, we are also working on, for lack of a better term, facets. For example, security. Security is important, especially if you are talking to people in finance, in the DoD, CIA, in public sectors. Okay. And searchability. You have your graph data, but I want to find something of interest, right? What kind of search capabilities do you have? User interface. This is a very important one. If you have some technologies, but without a beautiful interface, nobody will look at your stuff, okay? So that's why we are working with our partners from Tom Sawyer and other companies to provide a nice UI to the graph technologies. And programming interface, we need Java, we need Rust, we need SQL interface, etc. And tools, okay? Scalability, people expect, your system can scale to billions of edges, to trillions of edges. Okay. Multiple platforms. These days, people care about Hadoop platforms. There are also people care about relational platforms and cloud. And fashion. Okay. So this is not a typo. From time to time, we are distracted by fashion. Like 5 years ago, MapReduce was really hard. If you are not doing MapReduce, some people won't even talk to you. Okay? Nowadays, I think Apache Spark and Elasticsearch are in fashion. So fashions are not bad. You know, there are a lot of good stuff there, but sometimes it can be a distraction. Last but not least, the solution. So many of the stuff here are just technologies, okay? But to end users, oftentimes they need solutions, okay? They don't want to spend so much effort to deal with security, user UI, etc., right? They want a solution. So all those facets are also something we are working on at Oracle. Now, the talk is about bridging RDF and property graph data model. So quickly, an RDF model, well, it's a graph model. You have vertices and edges between vertices, right? What is unique here is, in RDF graph data model, we are using URIs, Uniform Resource Identifier, to denote the vertices and also edges, okay? This unique resource identification is kind of crucial to RDF graph data model. There's a tons of standards, okay? RDF, OWL, SCOs, the query language SPARQL, RDB to RDF, okay? You name it. There's probably more than 10 relevant standards in this area. Now, property graph data model is quite a bit simpler. Fundamentally, it's also a graph data model, right? You have vertices and edges. People tend to use key-value pairs, right? Rarely you see people using URIs in this graph data model. With property graph data model, you can easily associate a key-value pairs on edges. You can do the same thing with RDF graph data model. It's just a little bit harder. So at Oracle, we are supporting this kind of two graph data models. There's a little bit of a difference in their use cases, right? For property graph data model, we tend to use them for graph search, graph analysis, right? For RDF data model, because of the URI, because of the semantics, okay? So it's better suited for knowledge representation, knowledge discovery, and data integration. Now, to give you a quick overview of the RDF graph support we have. There are 4 big categories of functions, right? We allow you to store, to load up a graph and triples, quads into the Oracle database. We support a variety of different ways to query the graph, right? You can run SQL-based graph query. You can run SPARQL. You can use Java APIs to query the data. We have powerful reasoning natively in the database. And we also allow this plugin architecture. You can integrate third-party reasoning engine, like Trial or Palette. And because the data sits in the database, right? So we can easily feed the data to tools that understand SQL, understand relational model. For example, the BI, Oracle Business Intelligence tool, or Oracle Data Mining. Okay. There are a lot of RDF products there. So there are a few differentiators, right? Security. We offer enterprise-grade security. Okay. We can protect the edges at triple level. We also scale extremely well. So this is one of the benchmark we did, I think in 2014, 2 years from now. We are benchmarking against a graph with a bit over than 1 trillion edges. Okay, and this measures the query performance, the data loading performance, and inference performance. So the throughput are all well over 1 million operations per second. Okay. So very large graph and very efficient operations. Now let me give you a quick overview of property graph support. So this shows the architecture. As a backend, you have a choice of databases like Oracle NoSQL database or Apache HBase. So these two are for the big data platform. And in the upcoming Oracle release, we're going to have property graph schema in Oracle database, so native PG data storage. There's a common graph data access API, which abstract out all those details, right, across those three different backends. We offer Lucene integration and Solar Cloud integration to provide a really efficient graph search. On top, we have this very important component called Parallel Graph Analytics, okay, PGX. So it's a work from Oracle Labs, and we are really proud of it because it can run really efficient graph analytics in parallel, and it gives super good fancy performance. I'm going to show some of the numbers quickly. And as far as the format goes, we support GraphML, GML, GraphSyn, and Oracle-defined flat files, and CSV, and also you can pull out data from relational tables and convert it into PG format. So this shows a performance comparison between Oracle in-memory analyst, the parallel graph PGX, and Apache Spark. Okay. So this is a log scale. The lower, the better. So we are comparing a single instance in-memory analyst PGX with 16-node Spark cluster setup. Okay, the performance is much, much better for hop distance, for eigenvector centrality, and similarly for we conducted a comparison with GraphLab, which is one of the leading graph analytical engine. So here we are evaluating PageRank and the triangle counting. So this is a Web UK graph, has about 3 billion edges. Okay. Again, this is in log scale, the lower the better. We tried the in-memory analyst, the PGX, on 2 different chips, okay, x86 and Oracle Spark. So with Spark, there's a lot of threads. We can go all the way up to 1,000 threads. So this PGX can really leverage modern computer architecture. Yes, more threads. Yeah. And this one gives you an idea of the underlying database performance. Okay, we are using 8-node NoSQL database cluster, pretty small. But as you can see, as we increase the graph size, right, from a few million edges to all the way to billions of edges, right, the data loading speed remains pretty much constant. Okay, and the time is linear to the size of the graph. If you have a larger cluster, then you can get even better performance. Okay, so on a BDA cluster, big data appliance, if we are set up 4-node cluster in a BDA, in a bigger box, right, you can run triangle counting and finish the computation in just a few seconds. So this is against the LiveJ graph. It has about 70 million edges. So just a few seconds, really fast. Now, I have introduced both the RDF graph data model and property graph data model. You may wonder what are strengths and weaknesses, right? Depends who you are talking to, okay? People have different views here. So this is kind of subjective. The strengths of RDF, in our opinion, it has a really strong and formal theoretical foundation, right? There's a description logic, you have entailment, right? You have inference, you have consistency checking. In addition, you have a lot of well-defined terms like uniprot, well-defined ontologies. So those are really of great value. If we look at the strengths of property graph, it's easy to learn. There's not much to learn, actually. There's no standards, there's no specification for you to read. And here you have hundreds of pages. And property graph is more suitable for SNA, social network analysis. Now let's look at the not so pretty side. Okay? For semantic web and RDF graph, the learning curve is steep. Okay? And also there's hidden complexity. So what do I mean by this? Right? Sometimes you will see folks give you a SPARQL query 20 pages long. Java may have, an even more sophisticated SPARQL query. So there are a lot of hidden complexity here. The language itself, looks nice, but if you don't use it carefully, you can shoot yourself in the foot. On the property graph side, there's no lack of a standard. Okay, there's no standard query language, and because people tend to use just key value pairs, right? People tend to use keywords, so it's hard to deal with multiple property graphs. Now let me zoom in on the query language a little bit. On the RDF side, we have the well-known SPARQL query. It's a standard from W3C. You have a select, you have your projection. The variables have this question mark before the variable name, and you have the query patterns. For property graph, there are quite a few language proposals out there. From Oracle, we stand behind PGQL, and from Neo4j, there's a Cypher, and there's Gremlin and GraphQL. Okay, there's quite a few different proposals out there. So PGQL is a shorthand for property graph query language. Okay. Why do we design such a language? A key motivation is this has quite a similar syntax when you compare against the SQL, because like it or not, there are still a lot of SQL users. Okay. This shows you an example of a PGQL query. You have a select clause, you have from a graph, right? There's a while clause here. You define your query pattern, you define your constraints and filters. There's a bunch of modifiers like a group by, order by, limit, and offset. So this looks quite a bit similar to SQL. Okay. And I want to point out, we have PGQL support in the product we just released on Big Data Platform. Now, I have good news to announce. Many thanks to Oscar, Hassan, and Sumpak and their team from Oracle Labs. We just recently open sourced PGQL. So it has dual license, Apache license, and universal permissive license, UPL. The parser itself is open sourced. You can download it and play with the parser. So you can stick in the query here and call PGQL parse, right? You get back the result. If there's an error, you get error messages back. Otherwise, you get a graph query. So this shows you some of the key attributes in a graph query, right? This is a very generic graph query interface. Okay, you have projection, you have your patterns, group by. In a way, this is just a Java representation of an abstract syntax tree. Now, we have seen the strengths and weaknesses of these two different graph data models. The question is, can a single application make use of both graph data models? Okay. We have RDF here, we have PG here. can they be used in a single application? The answer is yes. Okay. Of course, there are many, many different ways to achieve this. Here is a simple workflow. Okay. Step 1, stick them in the same repository. Okay.